All right, guys, we're going to be working on overlapping triangle proofs. The word right there, overlapping, that's a big deal. That's the theme of the whole worksheet. These are definitely a step up from what we've been doing. The next test is going to have 2 proofs on it, and they will be amongst some of the highest level proofs we've had to do. So we're going to work real hard. I'm going to do one right now. This is what we did after the quiz today. We're going to work a lot more on this on the next time. The big thing here is understanding overlapping and what it means. And these proofs just are harder right from the beginning. Like, look at this picture. How many triangles do you see in this picture? There's a lot. There's 1, 2, 3, 4 small ones, but a lot of you might have said just 4. But hey, here's a 5th, here's a 6th, here's a 7th, and here's an 8th. There's actually 8 triangles in this picture. And so knowing which triangles are congruent and why they're congruent and keeping track of all the things you have, it's not the easiest task. But what does overlapping mean? So like if I were to draw this triangle here, this pink triangle, and its friend, this other pink triangle, do they have any overlapping parts? What does overlapping mean? It means that they share a side or they share an angle. Well, they have vertical angles, but that's not overlapping. Yes, they're congruent, but that's not what I mean when I say overlapping. So no, these 2 shapes do not have any overlapping parts. Now, if I were to draw this bigger triangle here, does that have any overlapping parts with the pink triangle? Overlapping parts, do they have any shared sides or shared angles? And the answer is yes. They both use the side KA. So the pink triangle and the blue triangle both use KA. If I were to name them, KA would be in both those triangles' names. Now, a lot of you might be looking and be like, how about KD? Well, does the blue triangle have a side called KD? It does not. Now, KD is a part of one of its sides, but it's not the side. That is not an overlapping part. But what about this angle up here? I'm going to call it angle 1. Do both triangles use that angle? Yes, that would be another overlapping part. So seeing where and how triangles overlap, that's going to be a big key to being successful in these proofs. All right. And then I'm going to give you a little cheat code that I'm going to let you guys use. When you see perpendicular lines create 90-degree angles. And if more than one angle is 90 degrees, then those angles will be equal or congruent. So we're going to go straight from perpendicular to congruent just to make it a little bit easier. But does perpendicular actually mean congruent? No. Perpendicular means they're 90. 90 means they're congruent. It would take a few steps. So just so you know, when I do these, a little bit of a cheat code there. It just saves a little bit of time. And it's going to come up pretty often. So they tell you KA and AR are perpendicular. So I'm going to mark that in my picture. And then they tell us YR and AR are perpendicular. So if they're both both sets of lines are perpendicular, we know that those corners are both 90 degrees, which means those angles are in fact equal. So I'm going to write my proof. I'm going to number those. It might be kind of hard to see, but I'm going to call this angle 1 and this angle 2. And I am going to hit, there's all my given stuff. I'm going to say angle 1 is congruent to angle 2. And I'm just going to say definition of perpendicular, even though that's not correct. Or you could say like perpendicular lines lead to congruent angles. You can use either one of these reasons. I'll be okay either way. So, but it's because the perpendicular lines make them 90 degrees, and we know that if they're both 90, then they are in fact congruent. All right. Then the other thing they tell us is angle AKR, that's this angle at the top, and angle RYA, that's this angle at the top. So remember, when we're proving triangles congruent, we need 3 parts, right? Like SSS, 1, 2, 3 parts. SAS, that's 3 parts. Every one of our congruency methods has 3 parts. If you have 3 parts, you can build the triangle, unless it's SSA or AAA. So we're not looking for that. But we need 3 parts of a triangle to build it. So this is where it gets a little tricky. We're looking at the picture. What triangles do we have the most parts for? Like if I draw KDA here, I don't have the most parts. I have 1 angle. That's it. How about if so this is what I want you to do. Trace, if I give you angles, trace the sides of the angle. I trace that 90, right? If I keep going up and I keep going over, can you tell what triangle I'm making with the 90? Yeah, and then I'm going to trace this other angle. That purple triangle I have, and sometimes it helps to draw it off to the side so you can kind of see what you're working with. We have a 90 and we have the angle at the top. I have 2 parts of that purple triangle. How about its red friend over here? Also 2 parts of the red triangle. So I just need a third part. Now, I've already used my entire given, so there's nothing left there, but is there anything we know because of the picture? And the answer is yes. That's the whole theme of the unit. Do these triangles have overlapping sides? Yes, yes, yes. This side here, they both use. So in my proof, I'm going to say AR is congruent to AR, and that's the reflexive property. And that would be this side down here. So do I now have three parts? It's angle, angle, side. I got it. So I can now say triangle KAR is congruent to triangle YRA. You got to name them correctly. And that is angle, angle, non-included side. Angle, angle, non-included side, AAS. I'll tell you right now, on the test, if you can just get me one pair of congruent triangles, I'm going to give you over half the points. The rest of the points are going to be really hard to get, but that's over half of them right there if you can get that far. So keep that in mind as you feel the burn, as these get really tough. Just do as much as you can. You're going to get a lot of points. Just don't quit on me. So the next thing I would do is, what do I actually want to prove? Because once I have one pair of congruent triangles, at that point, I need some direction. Well, DK and DY, I'm gonna highlight those. I need these to be congruent. So I got to ask myself, how do I get there? And there's really only one good way to get there. If I were to finish this triangle, right, doesn't that use DK as well as an angle that we have? Like, you're trying to draw triangles that use the parts you want and parts you already have. So if I were to like draw a little sketch of the green triangle so we can kind of see what we're working on, right now we have the angle at the top. And we can get, I'm going to call them angles 3 and 4, we can get those vertical angles real quick. So angle 3 is congruent to angle 4. Those are vertical angles. So they use vertical angles. We already had the angle at the top. These are the only triangles we can really use to get us DK and DY here. And this is the hardest part right now, is we proved triangles were congruent. Once you do that, you're looking for ways to use those triangles. Does this triangle KAR, highlight it again if you need to, draw it again if you need to. If you draw a triangle KAR, have you drawn any parts of the green triangle we're trying to get? And the answer is yes. There's the overlapping side, KA. So the green triangle overlaps with KAR. They both use KA. Look at the name. What does KA go with? YR. So we can say that KA is congruent to YR. How did we know that? It's because of the triangles. And if it's because of the triangles, we say CPCTC. Don't ask me how to spell that. I'll get really mad. All right. So we have that side. So go back up here. What do we have? Well, I'm going to put a double dash. We got this angle. That's the vertical. I'm going to put a double dash there as well. We have this side. We have angle, angle, non-included side. We can now say triangle KDA, my favorite band, is congruent to triangle YDR. And that is angle, angle, non-included side. Can we now say DK goes to DY? Well, look at that triangle. DK, DY, let's go. DK is congruent to DY, and that is CPCTC. Don't ask me how to spell that. There we go. That's tough. We're going to work through these much more next time. This is a little preview of what we're getting into. If you can get the first 4 steps, give me one set of congruent triangles, you're getting over half the points. The rest of it's hard to do, but with practice, we're going to get there.